Hello, and welcome to Econ Movies. I'm your host, Shauna Pallov. Today we're going to be talking about 5 econ concepts that everyone should know about, and they're all related to firms. These econ concepts include profit maximizing, perfect competition, monopolies, monopolistic competition, and oligopolies. Now, for our first concept, which is profit maximizing. What is the first thing that comes to your mind when you hear that? It's making the most money possible, isn't it? Well, technically not in econ terms. In econ terms, profit maximizing is producing at a quantity where MR is equal to MC. Or it is this point in the firm's graph where they make the most profit possible. Now, this may all seem new to you, but here, let me simplify it. All types of firms have to follow this rule, as they will thrive in the industry and they will also stay in business. So, perfect competition, monopoly, or monopolistic competition, or even oligopolies. They all follow this rule. So MR is marginal revenue, which is the revenue generated from selling each additional good of that product. Whereas MC, or marginal cost, is the cost of producing each additional good of that product. Now, at lower quantities, MC always starts below MR, and then it comes up, crosses MR at MR equals MC, and then goes above MR. And by the way, always produce at MR equals MC, most profit. And so, even when MC goes above MR, never consider that. Always produce at MR equals MC, never consider when MC goes above MR. Now, again, everyone follows this rule. And so let's see some examples so we can understand better, shall we?
Okay, now for the example for profit maximization. So, as we can see here, profit should be at its highest when MR equals MC. So here we can see total revenue, total cost, and a profit table. So, now if you look closely, you see the highest profit, okay, out of here is the 90. Now, the highest profit is 90, so the marginal revenue here and the marginal cost for the 80th unit should be equal. So now let's calculate the marginal revenue and marginal cost for those. So marginal revenue there and marginal cost there. Okay. So marginal revenue from here to here is $40, and 190 to 230 is also $40. So that's right, 40 is equal to 40. And we have, so when MR is equal to MC, we have our highest possible profit, which is $90.
For our second concept, perfect competition, these are one of the main types of firms, and they also follow the profit maximization rule. There's thousands of these firms, and they're very common in the real world. One of their unique characteristics is that they produce very identical products. Firm 1's orange, Firm 2's orange. They're both oranges, made by two different firms. And because of this, these firms can't really advertise because they have the same product. One of their special characteristics is that they have very low barriers to entry and exit. They're also price takers, which means that they basically have to accept the prices set by the industry for their product. So this orange, the firm wants to sell it for $4, industry equilibrium has set it to $1. So they basically have to sell this orange for $1 and not $4 like they want it to. These firms also make no economic profit in the long run because they achieve both of the efficiencies in the long run, which are productive efficiency and allocative efficiency. Productive efficiency is producing at minimum ATC, whereas allocative efficiency is producing where society wants them to produce. One special thing about these firms' graphs is that their marginal revenue curve is the same as their average revenue curve, which is same as their demand curve, which is same as their price curve. So an acronym for this is Mr. DARP, so you can remember better. Now let's look at some graphs.
Now for the graph for perfect competition. As you can see, this is Mr. Dark here. is also Mr. Star here. So price, marginal revenue, demand, and average revenue. Here we have our MC curve, marginal cost curve, starts below, and then rises, touch crosses MR, and then rises. We should always be producing at MR equals MC profit maximization, so this point right here. So by the way, this is the firm, and this is the industry. Same here, firm, industry, but this one's for short run equilibrium, and this one's for long run equilibrium. So the difference here is that let's say shutdown rule. So if the firm's gonna shut down, ABC is gonna be here. It's gonna be above price. So when ABC is above price, that means to shut down. Okay, and ATC. Okay, and let's say this is ATC. If this is ATC and then ABC is here, you keep going because ABC is not above price, even though you're taking a bit of loss. As you can see, this will be your loss if this curve was ATC curve. So yeah, you should still keep going. And if the ATC is below price, that is the best situation to be in. Now here, let's move on to the long run equilibrium. Here, as we know, as we talked about before, long run equilibrium is productive efficiency and allocative. So our ATC, minimum ATC, would be MR equals MC. Well, minimum ATC would be price. Yeah, this is being productively efficient at minimum ATC, and we're also being allocatively efficient because we're producing at MR equals. So in long run equilibrium, as you can see, we're making, well, no economic profit. So there's going to be no economic profit. And we're just going to be making a normal profit. And here, there's yes to both efficiency for long run equilibrium or perfectly competitive. So these are the graphs, and let's move on to concept 3.
For the third concept, monopolies, this is another type of firm who follows the profit maximization rule, and these firms are very, very rare in the real world, as there's only like one of them in a specific industry. Monopolies also make very unique products that have no substitutes. And because of this, they're price makers. They can set the price of their product to whatever they want, as people have to buy from them anyways. Monopolies also have very high barriers to entry and exit, and they do make long-run economic profit, unlike perfect competition firms who don't make any long-run economic profit. And this is because monopolies are very inefficient. Monopolies can also price discriminate, which is basically set prices to different customers, and they can also do non-price competition, which is basically comparing the product itself instead of comparing the prices, which is because they have no substitutes, so they have to compare the product when monopolies are competing each other. Now let's look at some graphs, shall we?
Now for graphs for the monopoly, as you can see here, this is the short run equilibrium graph for monopoly, and short run equilibrium in monopoly is the same graph as long run equilibrium in monopoly. There's no two different types of graphs for monopoly like perfect competition had, where they did not make any economic profit. But here, monopoly short run equilibrium graph, same as long run equilibrium graph. Now this AR curve is the same as the demand curve, which is the same as the price. So this is all the price curve right here. This is marginal revenue, profit maximization, obviously MR equals MC right here. So we're going to produce at this quantity, and if this is the price, and this is the average total cost, that means this is our profit right here. We're making this much profit. If this is the price, this is the average total cost. And this will be our profit in this case. And shutdown rule for monopoly, same as perfect competition. If AVC goes above price, then shut down. So that's the same. So let's say this curve wasn't here, this ATC curve wasn't here, and this curve wasn't here. Okay, we're just assuming that. And okay, let me erase this. Okay, there we go. So yeah, assuming that this ATC curve wasn't here, right? And this was the AVC curve, and this was the ATC curve, assuming, we could clearly see MR equals MC quantity. This would have been our loss, but we would shut down because AVC is above the price. So yeah, we would shut down if AVC goes above the price. So you can see that. And like perfect competition, if AVC was below the price but ATC was above the price, we would take the loss, but we won't shut down. But if AVC goes above the price, we would shut down. ATC is above the price, AVC is under the price, we would still keep going, not shut down. And now, here's another concept for the graph. The second MR crosses the x-axis, that quantity, after that quantity, it's inelastic, and before that, it's elastic. Here, it's inelastic. The demand curve, or AR curve, or the price curve, same thing. Yeah, so once MR crosses x-axis, it gets inelastic. When MR is before the x-axis, it's elastic, and when MR touches the x-axis, that's unit elastic, as you can see here. Elastic here, unit elastic here, and after MR crosses the x-axis, it's elastic there. So yeah, and this is another concept right here. This is basically the same thing as here. Just saying that this firm is gonna shut down because AVC is above price. Also, AR is price. You should do it. Okay. Yep. There you go. So that's short run, long run in monopoly, shutdown rule in monopoly, elastic and elastic range in monopoly, and also the price discrimination happens when the demand curve. So this curve, this demand curve right here is the same as the MR curve. So this MR curve would be the same as the demand. So it would be exactly on top of the demand curve too. That's when price discrimination occurs. And that's basically all the concepts for monopoly. Now for concept 4.
For the fourth concept, monopolistic competition, this is another type of firm who follows the profit maximization rule, and there's hundreds of these firms in the real world. Many of its special characteristics include that they make differentiated products. So, because of this, they advertise a ton a lot. These firms also have excess capacity in the long run. And their graph is similar to a monopoly's graph, but one difference is that their demand curve is more elastic than a monopoly's demand curve. Like a perfect competition firm though, this firm makes no long-run economic profit and has low barriers to entry and exit. But like a monopoly, this firm is a price maker and engages in non-price competition. And it's also inefficient. Now let's look at some graphs, shall we?
For the graphs for monopolistic competition firms, these look very similar to monopoly graphs because they are monopoly graphs. For excess capacity in the long run, as you can see here, they produce at the MR equals MC profit maximization quantity, which is what they should do. Yes, they should do that. I agree. But their full potential, their full capacity, they can actually produce up till here, where MC crosses the ATC curve. So they can produce up till here. So this is their excess capacity that they could produce if they ever wanted to. Now, for long-run equilibrium, it's basically, because they don't make any long-run equilibrium economic profit, it's basically the perfect competition graph perfect competition principle on a monopoly graph. So yeah, this is when the price is equal to ATC. So they make no profit, no econ profit. And this is only for the long run, okay? As you can see right here, MR equals MC quantity, price is ATC. There you go. And this is for short run, obviously, this graph right here. And as you can see, they're making some profit. This graph, I got these graphs from the internet, so some of them are wrong. Let me just correct it. Okay. There, that's the correct quantity, where MR is equal to MC. That's the correct quantity they're producing at. And this profit should be a bit smaller. Oh, there we go. So this is their profit right here. It should also be above. Oh, perfect. So MR equals MC quantity. They're producing, this is the price, this is the average total cost. So their profit is this right here. This black square is their profit. There we go. For shutdown rule, it's the same. If AVC is higher than price, then shutdown. Same for all the firms, basically, even though no comp. As you can see, this firm was shut down. As the MR equals MC quantities right here, and the price is this much, and AVC is over here. So as you can see, AVC is greater than price, so shut down. So this monopolistic competition firm was shut down.
For the fifth concept, oligopoly. This is another type of firm who follows the profit maximization rule, and there's about 10 of these firms in one specific industry in the real world. These firms perform collusion and use strategic pricing tactics to defeat the opponent firms. These firms also use game theory matrices to do what's best for them and set their prices that way. You will see those later. These firms have very high barriers to entry and exit, are price makers just like a monopoly, and yes, they're very inefficient. Now let's look at some graphs and game theory matrices, shall we?
For the graphs and game theory matrix for oligopoly. As you can see, this is a game theory matrix right here. And these are the two types of graphs. Oligopoly graph is the same as a monopoly graph. Basically, they're the same thing. Short run or long run. And this is another type of oligopoly graph called the King's demand curve. It's not used very often, so we won't go over it, but I just wanted to point out that it does exist. And now let's look at this game theory matrix. Now, it's kind of like finding the best for both of them. So, as you can see, player 1, his choices are 60, 30, 40, 120. Which one will he go, A or will he go B? Well, 120 is definitely higher than 60 and 40 is higher than 30. So player 1's dominant strategy is to go B and not go A. So player 1 won't go A. Now let's look at player 2. If player 1 goes B, what will player 2 do? 30 is bigger than 0. So player 2 will go here, A, if player 1 goes B, which player 1 will go B, because he gets more. And if player 2 gets to choose first, the last turn player 1 got to choose, so he went B and player 2 went A. If player 2 gets to choose first, then player 2, well, 60 is more than 30, 60 is less than 120, and 30 is more than 0. So player 2 would want to go B, okay? So no matter what, player 2 wants to go, like player 2 can change what he wants to go. Player 2 can go A if player 1 goes B, and then if he can go B if player 1 goes A. So like player 2 doesn't have a dominant strategy. Player 2, no dom. Okay? But player 1, no matter what happens, if player 2 goes A or B, player 1's always going to go B because Both of these numbers are hard. And player 1 is always going to go B. So as you can see here, if player 1 is always going to go B, what is player 2 going to choose? A. So here's the Nash equilibrium right here. This is our Nash equilibrium. Like that. B, A. So player 1 goes B and player 2 goes A. That's our Nash equilibrium. That's what they will do in the real world.
That concludes our economics adventure about firms and the Econ movie. I'm your host, Sean Apollo, and I'll see you back in semester 2. See ya for now.